What's up, everybody? Day 2 of Advent of Code 2015. Let's jump into it. I was told there would be no math. The elves are running low on wrapping paper, and so they need to submit an order for more. They have a list of the dimensions length L, width W, and height H of each present, and only want to order exactly as much as they need. Fortunately, every present is a box and a perfect right rectangular prism, which makes calculating the required wrapping paper for each gift a little easier. Find the surface area of the box, which is 2 times L times W plus blah blah blah, this formula. The elves also need a little extra paper for each present, the area of the smallest side. For example, a present with dimensions 2, 3, 4 requires 52 square feet of wrapping paper plus 6 square feet of slack for a total of 58. So the smallest side. The area of the smallest side, 2 times 3, okay, here is 6, so that's what we need as slack. So we have 52 plus 58. A present with dimensions 1 times 1 times 10 requires 2 plus 20 plus 20 is 42 square feet of wrapping paper plus 1 square foot of slack for a total of 43 square feet. All numbers in the elves list are in feet. How many total square feet of wrapping paper should they order? So here's the input. Let's look at the example input and put it into our input here, and I copy this as well. Well, actually I'll just leave 1 here for now. Then, this is one of my favorite parts, I delete all the code from yesterday, and we can get going. So what we can do is, for each line in this list, which only has 1 line now, I can print, see if it worked, and check again. The formula is this plus the smallest area, so I get 3 areas and 3 areas and this area. Okay. Once more. Okay, we should get 3 areas. Well, first we need to like read these things. Okay, what we can do? We can split by x this line, so we get a list of numbers that are currently still strings. So we map them to int, and this is our list of numbers. Here is the list. A is the first one. Does it matter? L, W, and WH and HL are kind of interchangeable, so I can just go calculate all the areas. I'll just calculate them. 1. Or let's get the first area is L1 times L0, and the second one is L1 and 2. Obviously everything needs to be times 2. and then C is 2 times L0, and then we have the smallest one, min of A and B and C, but I don't think we can put 3 in there, can we? Let's check. What does it say? Here, this function Kotlin math min takes 2 arguments, so I just use 2 of them. No, I will use, yeah, min of B and C, and then min of A and the minimum of B, that's the smallest, and then we can add them all. A plus B plus C plus smallest is my result. Int for now. And we can add this thing. Oops, what did I get there? Result dot add. Print this. So we have 64. Yeah, the problem is we added 2 times 6 instead of 6 to the as the smallest area. So we could just divide it by 2 to offset it again. And then we get 58. And then if we try this example and run it, 43, which is what we want. So we can check the full list. Then we have all of them, and then we can just do sum. Get a big number here and see if this is correct. That's correct. Okay, so let's just talk through it again. We needed the 3 areas and the smallest one once more. But the smallest one, the area is just this. And we added times 2 because of each side of the package needs to have a area, but the smallest one is only 1, so we offset it again by 2. This line, yeah, each line is just a number, x number, x number, so we split it by x, which gives us a list of integers, well, of strings. Maybe I can show this. The line is this string. And if I split it, then I get a list of the individual numbers. Then all I have to do is map it to ints, so that I have a list of ints, correct types, so I can add ints, because I can't add strings. And then the rest is obvious, we just do the formula from the instructions. So let's go to part 2. The elves are also running low on ribbon. Ribbon is all the same width, so they only have to worry about the length they need to order, which they would again like to be exact. The ribbon required to wrap a present is the shortest distance around its sides or the smallest perimeter of any one face. Each present also requires a bow made out of ribbon as well. The feet of ribbon required for the perfect bow is equal to the cubic feet of volume of the present. Don't ask how they tie the bow, though, they'll never tell. For example, a present with dimensions 2 times 3 times 4 requires 2 plus 2 plus 3 plus 3, 10 feet of ribbon to wrap the present, plus 2 times 3 times 4, 24 feet of ribbon for the bow. Okay, around its smallest perimeter of any face. So we just take the small ones and add them. To wrap once around the present, and then we do extra calculation for the bow, and then we add those. How many feet of ribbon should they order? So we get the two smallest sides, add them each twice together, and then we multiply all the numbers. So we make another list. Part 2 is list of ints. We get we sort list L, so we have the smallest first, and then the second smallest second, and then we take the top two. Smallest two, and then we wanna, I think we can just add them and multiply by 2. Sum them times 2. This here. Well, I can put everything here. It's like part B area. 2. Smallest 2 dot sum times 2 is 1 part, and all of them added is the other, plus all of them multiplied is the other, b times c, no, not a times b times c, L1 times L0 times L2. Then we'll have a look at this result. And we will try it with this example. Let's just try this one. We would like to see 34, and we see 34. Okay, then we can do sum and get the second number for the ribbons, and that's correct. And we got 2 stars. So what we did is sort the list and take the top 2. So in the first case, if we have 3, 11, 24, we get the smallest 2 to be 3 and 11. And then we get the sum of those, which is 14, and 2 times 2, because 11 plus 11 plus 3 plus 3 is the same as plus 3 times 2. True. So then we can do this part, and then we add the multiplication of all the elements in the list. And then we get the ribbon length. That's it for today. Thanks everyone. See you next time.